Thanks for joining us for another episode of DPC Radio. This episode was recorded live in Amsterdam at the Dutch PHP Conference 2012. For more information about the Dutch PHP Conference, visit our website, phpconference.nl.
Okay, welcome everyone. So I hope you had a great lunch. Hope it wasn't too good of a lunch, because I'm handing out Dextro Energy, and that's not because this is going to be such an easy talk. In fact, it's I've been told that it's quite a hard talk, technical talk, and we're going to put the P in DPC. I'm actually going to show quite a lot of code and some YAML. And let's talk about parsers. First off, I'm Baukema, software engineer at iBuildings, and recently I was listening to a podcast by Software Engineering Radio. I don't know if you, who here has heard of Software Engineering Radio? It's an excellent podcast. There's a link at the end of the slideshow. And Martin Fowler was speaking on DSLs. Who here does not know what a DSL is? Okay, great. A lot of you know. For those who don't know, a DSL is stands for domain-specific language. It is a language constrained by a particular domain. For instance, Google's search syntax is a domain-specific language. You can't assign variables. You can't do if statements, while loops. You can only specify what you want to search. SQL is a domain-specific language. CSS is a domain-specific language. These are all pretty big and successful domain-specific languages. And Martin Fowler was talking on compilers and compiler writing. And he said there's a common fear of writing compilers. And he thinks there are two reasons for that. One is developers never took compiler class at university. And the second is they did, and they know it is hard. I'm ashamed to say I belong to that first group. I never did take that first semester of compilers at university. But I did have parsing problems. Notable problems that I've run into are converting a lot of documentation from one markup language into another, into this year's flavor of the year, specifically from Track to Wikimedia. Validating templates, which were partly HTML, partly Smarty. Building query languages for RESTful APIs, and giving users an option to search in a rich content model using something like Google's query language. Now, I'm sure you all have your own parsing problems. Domain-specific languages are a great example of what you can do with parsing. Douglas Crockford mentioned yesterday that we need to raise the level of abstraction. I believe that parsing languages is the way to raise the level of abstraction. And in this talk, I'm going to show you how. I'm not going to delve too much into the compiler theory part. I know that is scary. It's scary for me too. But I'm going to show you the working examples of how to build a parser. And I believe it's important. Why do I believe it's important? It's because we work with a lot of languages every day. Some developers say they only work with PHP. I think that's a lie, because in my day-to-day work, I build my programs in PHP. They run at the request of something called HTTP, and they are run by Apache, which is configured in its own language. They do queries in SQL. They do queries in LDAP. They return another language, HTML. They return more script to be interpreted at the browser side, namely JavaScript. And our world is filled with languages, we as web developers. And one of these days, you're going to have to figure out what one program is telling another in a specific language. So let's go do that. little look ahead. First, we're going to be talking about languages, formal languages. Don't be afraid, it's not as scary as it sounds. It's a way to describe what we need to parse. And if there's nothing else that you take away from this talk, I hope you take away how to read formal languages, because as we'll see, they are everywhere. Then we're going to talk about the actual act of parsing. I'm going to show you two ways of implementing a parser. One using a parser generator. The next is manually building a parser. After that, I'm going to be discussing parsing PHP code. If you've ever tried to parse PHP code using regular expressions, don't. There are lots of tools out there. I'll show you one which is fully capable of parsing PHP and giving you an interface to do your own introspection on your PHP codebase. And finally, I'm going to give some resources for those of you who want to learn more about the act of parsing. So, smart and talented developers look at a parsing problem, and often they think, I know, I'll use a regular expression for this. And now they have two problems. Have you ever wondered about the name Regex, where it comes from? I know Regex stands for regular expressions, but some of the regular expressions I've seen don't seem quite so regular to me. I mean, if this is regular, I really wonder what special is. This is an example taken from a Perl module which tries to parse RFC 822, which is email addresses. And yeah, this is only part of the irregular expression. So yeah, regexes have a much longer history than Perl, which we all know them of. Regexes were introduced by Ken Thompson and Dennis Ritchie into Unix. Perl took it from there and extended it. But before that, they were a notation to describe something known as regular languages. In language theory, there is a hierarchy of classes of languages. The lower being regular languages. What makes a regular language regular? It's that it can be described by a regular expression. What makes a regular expression? It parses regular languages. Doesn't tell you anything. But regular languages can always be parsed by a finite state machine. A finite state machine, we've all probably seen it. It has states and transitions between the states. One thing that it's missing is memory. A finite state machine does not know where it has been before. If we want memory, and we do, because in programming language, memory is really quite handy. When we're parsing, for instance, a string that begins with an opening quote, we kind of want to match the closing quote, opening braces, closing braces, opening tags, closing tags. Memory turns out to be pretty important for programming languages. If we want that, we have to move up to context-free languages. And as it turns out, context-free languages have their own notation, namely context-free grammars. Sounds scary? It's not. This is an example from the HTTP spec. It is the accept header, because everyone here does content negotiation on their REST services, right? This is a Buckets narrow form grammar, or BNF in short. There are other notations for context-free languages, but this is the most popular one. This is the one you'll see mainly in RFCs. And like I said, if there's nothing else that you take away from this talk, this is the one bit that you need to take away. Let's not start with something quite so complex. Let's start with something a little simpler. This is a grammar for arithmetic expressions. It supports addition, multiplication, and sub-expressions. And if you look at it and you only know regular expressions, then you'll probably see a familiar notation. you'll see the pipe sign intended for alternation. So if you look at an even smaller example, simply constants, we'll see that a digit is defined as the string 0, the string 1, the string 2, 3, 4, 5, 6, 7, 8, or 9. And we'll see that a constant is defined in terms of a digit or a digit and a constant. This recursive nature is important. It's what gives us the memory that we need, the stack. If we look at an actual example of trying to parse a string using this notation, the string 1, 2, 3, then we'll see that a parser will try to match a constant. When it looks for a constant, it will want to know, well, what is a constant? A constant is a digit or a digit and not a constant. Both begin with a digit, so do we have a digit? Yes, we have a digit, namely 1. Do we have a constant? Well, what is a constant? A constant is a digit and a constant. It always begins with a digit. Do we have a digit? Yes, we have 2. Do we have another constant? Yes, a digit is a constant, or a constant is defined in terms of a digit. Is there another constant? No, there are no more constants. So the recursive stack collapses and we're done parsing. This is a very neat trick in order to get state, to get a stack. You'll note that it is also used, for instance, in sub-expressions here. A expression is defined as a term is defined as a factor is defined, has a sub-expression, a expression is defined as a term, factor, sub-expression. Does everyone get that? This indirection is important in grammars. Yes?
I don't think we can do simple addition with this grammar. It's the rule that says you can have an expression with a plus operand and then another expression.
You can have an expression with the plus operand and another term. A term is a factor is a constant is defined as digits. Good. Well, it's important that you get this. Like I said, if you get nothing else from this, at least learn how to read BNF. Because, as we saw earlier, it is in most RFCs, if something of a syntax is described, it's used. It uses BNF. One problem with BNF is that the syntax is so easy to describe that there are a lot of variants out there. The most common one of that is eBNF, extended BNF. And someone said there, this whole recursion is pretty nice, but matching more than one thing is something we want to do quite often. So why don't we just use the clean operators in our notation? The clean operators being 0, 1, 1 or more, and 0 or more. So in this is all well and good, but in 2004, a guy named Brian Ford, who's currently teaching at Yale, looked at this. And he looked at how parsers were actually being implemented, and he said we can do better. So he invented parsing expression grammars. A parsing expression grammar looks a lot like eBNF, except it makes 2 significant additions. The first being that because a constant is, by its very definition, always regular, we can describe it as using a regular expression, or a regex in this case. Before we go on, I have to clarify a bit further. Regular expressions in the computer science sense are not regexes that Perl has made them into. Perl added some pretty significant parts, namely look ahead and look behind, which make it more powerful than the original regular expressions. Computer scientists often use the original regular expressions, which look a lot like regexes. They're not. But Brian Ford said, well, so what if they're more powerful than regular expressions? Let them use regexes anyway. The second most important difference he made, the second addition he made was to allow for ordered alternation. In normal grammars, saying we want to match one token or the other, the parser needed to try both and then see which worked. If it got 2 matches, then it was considered ambiguous or an erroneous grammar. Brian said, well, this is not really how parsers are being implemented in practice. In practice, we simply use an if statement, and if the first one matches, then we'll use that. This is pretty nice because it allows us to step around ambiguous grammars. This is also pretty dangerous considered by computer science, but it's pretty nice for us programmers. So, boy, that's all well and good. You've been talking for 15 minutes now, but I want to actually learn how to parse a language. For that, you need a grammar. And if you have a grammar and your grammar is formally defined, then why do you actually need to write anything? I mean, what is our program if nothing but a formal specification of how to do something? In fact, we can use something called parser generators, which will take your grammar and write a parser for it. Unfortunately, there are a lot of tools, parser generators out there for C and C++, but parsing is not such a common occurrence in PHP that the parser generators are really of production value. You have line PHP and PHP parser generator, which are the ones that you'll run into quickly if you go out and look for parser generators. Unfortunately, they were created a while back and they have been unmaintained for some time. Actually, PHP parser generator is being used by Smarty currently, which I thought was interesting. So if you're working with Smarty code and want to extend Smarty, you might want to have a look at that. One downside of this is that there are direct ports of the Lemon parser generator written in C, and the documentation of PHP parser generator actually mentions, well, we don't have any documentation. If you want documentation, just go look at the C documentation. Doesn't make it really easy to maintain. There are 2 new ones, new parser generators. One is Loco, which was invented by a pretty smart computer scientist. Unfortunately, just a bunch of files up on his blog with little documentation. And there's PHP Peg. PHP Peg is a library created by Hamish Friedlander of the CTO of Silverstripe. And it's the one I'm going to be demoing today. Peg grammars, like I said, are pretty nice in that they allow you to use regexes and to get around ambiguous grammars. And it's the one I'm going to be demonstrating using a example language that I made for this presentation. It's a pretty simple language, querylang. It doesn't support much. It has terms, it has logical operators, and it has sub-expressions. And it has one important thing, that is precedence. If you look at this expression, you can parse it in one of 2 ways. You can say parsers or 1, 2, 3 and the sub-expression, or you can say 1, 2, 3 and the sub-expression or parsers. In this case, we've defined and as having a higher precedence than or, so we parse it in the way that is described below. So let's get started. Let's get started with PHP Peg. What you do is there's a parser class in PHP Peg that you extend, and at the top of the parser you define your grammar. Let's start with a really simple example, just the terms. We define a term as multiple word or digit characters, and that's it. Then we implement our own public method, the parse method, which calls match underscore term. Match underscore term is a method that is automatically generated by PHP peg, and it will try to match the term in our input. What it returns is an array, and in this array is the key text, which is what it has matched. If we look at the actual code that's generated by PHP peg, we'll note that it isn't very readable. Parser generators don't generally generate readable code, so best to ignore that and look at the actual output. If we instantiate our parser and give it an input query of test, then and we print the result, we'll see that we'll get back test, which is what we wanted. One problem, if we give it test 1, 2, 3, then it will simply return test because it doesn't know anything about whitespace. So let's add multiple terms. Here we have 2 productions. A production is a single line in a grammar. The first production defines a query, and a query is defined as at least one term, and following it, a whitespace, which is what the angular bracket is, an optional whitespace, and another term. And this can happen 1 or 0 or more times. Again, a term is defined as word or digit characters, and then we define our public parse method. Our parse method calls match query. Match query is automatically generated for us by PHP peg, and then we return not the text that I found, but we return query. Why? Because we have a language which has we have a query with multiple terms, so we might want to make those into actual objects. Here you see that whenever PHP peg encounters a query production, what it will do is it will call the query underscore underscore construct special method. In this, we define our domain model, our query object, and we set it in the result. The end result what will be returned from the match underscore query. Then, whenever PHP peg encounters a term in that query, we want it to add the text to a term object, and this term object should be added to the parent query. If we run this, then we'll see, yay, it matches our test 1, 2, 3. We get back a query object with 2 terms, test and 1, 2, 3. Everybody got this? Let's kick it up a notch. Precedence. The way you encode precedence in your grammar is you make it several productions, one calling the other. This is because our parser works by examining the left term first, looking up its definition, then seeing another. In this example, our parser tries to find a query. It will then try to match an AND query. Well, what is an AND query? An AND query is defined as a term. Well, what is a term? A term is either a sub-expression or a literal value. If it finds a sub-expression, then it loops back, tries to find an AND query, tries to find a term, etc. So as you can see, it will first try to look for a subquery. Then when it has found a subquery or a value, it returns that. Then try to look for an and another term. If it has found that, or if it hasn't found that, it returns and then tries to look for an or and another term or sub-expression. Again, in our public method parse, we call match query, and we return our query object. There should be no surprise. Whenever we find an AND query in our query production, we instantiate a query object. Whenever a query object is found, we instantiate the query object. Whenever a AND query is found, we add it to the query object. Same for the AND query production. The actual matching of terms is done in the following production, the term production. where if we find a query, we return that as a result. If we find a term, then we return that as a result. Now those of you who have worked with parser before know that the output is not going to be what we want it to be. The output is actually for a query A and B or C. It's actually going to be a query, a OR query, with two subqueries, two AND queries. Why is that? Because our parser doesn't do any kind of optimization. It just tries to find a query, which tries to find an AND query, which tries to find an OR query, which returns a result, but it will always wrap it in that query. This is no problem because we can add an additional step. In fact, if you look at compiler theory, you'll note that the bigger a compiler is, the more steps it has. This is a pretty nice, neat, and modular way of operating on your tree, your object tree that you generate. So in this case, we add an optimizer. I think you all know how this optimizer works. It just recursively goes down the queries, sees if there is a single term. If so, then it replaces the query by the term. When we run that, we get what we wanted, a query with a single OR query with a term and one subquery with A and B. Okay, that's pretty nice. Anyone have any questions about this? Yeah?
Is there any particular reason why C is now above the other one?
No.
The previous slide was below.
Yeah, it's just, it makes no difference, logically.
Yeah,
It's there because my private variable terms is defined before my private variable subqueries in the query object. So I could have reversed the order and then I would have shown it in reverse. Another question? Yeah?
Yeah, the example shown here, the order is always one. But this PHP pack is possible to have operators of equal weight, like in math, plus and minus is always left associated. And it's possible to implement something like that in the PHP pack.
Yeah. Yeah, actually that's even simpler than this because you simply put them in one production, put them with an alternation. So for instance, in our example, in this example, a subquery technically has the same weight as a value. In practice it doesn't because it's peg and it will try to find a subquery first. But if you're looking for something like a plus and minus, then you simply add the plus first and the minus second. It will never confuse the two.
Okay, so you could have just put and and or in the same statement and then put them equal weight.
Yes.
Okay, thank you.
Good. Good to see I'm getting through. Of course, there were parsers being built before PEG. I'm going to talk a bit about predictive parsing, which is a technique of manually building a parser. Some notable parsers have been built this way, namely DQL of Doctrine, the Gherkin parser of Behats, Twig of Symfony. So it's pretty interesting to see how this works, but if you've already seen how PEG parsing works, then this should look really familiar to you. One thing that is not going to be familiar to you is lexing. PEG parser generators do their lexing in the parser, which makes it more powerful actually than building a lexer. But actually, you don't really need a lexer if you want to go without. But lexing is nice because it allows you to not work on the individual character level, but to work on the, in this case, the actual term level, the actual terminals in your production. A terminal is a production that is defined as a literal string, where the parser can just stop following a direction and actually look up in the input if something is there or not. So in this case, in our lexer, the query A or sub-expression B would be converted to a term, an or, a left parentheses, another term, B, and a right parentheses. How this works, there is a complicated way of doing it. This is the simple way that most predictive parsers do it, simply by having multiple regular expressions. The most specific one at the top, the least specific one at the bottom. You'll note that we have a white space symbol, which we tell the lexer to simply ignore. If you look at the UML for the lexer, you know that it's pretty simple. We have an input, we have a lex method. This lexer runs our regular expressions and turns our input into a stream of tokens, just a queue of different token objects. That's our lexer. Once we have our token stream, we can then build an actual parser. The nice thing about predictive parsers is that you can take your grammar and translate it, translate your non-terminals simply to methods. And one method can call another method, which can call another method. So in this example, you can have query, call and query, call term, and for a sub-expression, it can call query again. This is how it does the stack that you need for a language. And we parse that to a tree structure. We've already seen that, the query and the term objects. This is the UML for that. We take a token stream, we run parse on it. Parse calls query, which can call and query, which calls term, which can call query again. If we look at an actual example of query, we see that we define a query object. We then try to find a left term by calling the and query method. We add it to our query, and then we look ahead in the input. We kind of cheat, as it were, and try to find a or token there. If there is an or token there, then we know that we have to match that or token. We can just throw it away because we don't need it in our domain model. But then we can call and query again to try to find the other term. One warning, predictive parsing works, and it works well if you define your own grammar. If you're using a grammar from an RFC, these have usually been written for other kinds of parsers. You might want to look at PHP peg for that. One thing to note is that you need a fixed look ahead. So far we've seen a grammar that has one token of look ahead. You could simply look at one token and see if you could use a rule. In this example, I have looking at one token doesn't help because it might you might have a sub-expression, in which case, yay, we can go. Or we might need to look at another token to see if we have a term value with a minus and another term value. And you can do left recursion, which computer scientists are always warning for, and I've never really found any parser writer that really thinks this is a problem, because we all know that if you define your or query method and then as the first thing you do call your or query method again, you're going to get an infinite loop. So make sure your grammars do not have left recursion. There's an automatic way of converting left recursion into non-left recursion, but I'll leave that up to you to find out when you run into it. So, but I want to parse PHP, and I don't have a grammar. Well, actually, there is a grammar. PHP uses a tool called Bison. There's a grammar. It's written in a format quite similar to what Lemon uses. I wouldn't suggest you actually look at it. I wouldn't suggest you actually try to build your own parser for PHP, because you're not the first. One project I found that has a pretty good PHP parser is actually not known for having a pretty good PHP parser. It's known for being capable of generating statistics over your code. But in order to do that, it needed a PHP parser, so it's in there, but it's called PHP Depend. Who of you here have heard of PHP Depend? Use it? Good. Yeah, it's an awesome tool. It generates nice graphics, but beneath it, nice statistics, but beneath it is actually a pretty decent parser that you can use. There are two more projects. The lower one, PHC, is an attempt at writing a compiler for PHP in C. I've recently found out that it's been abandoned. But if you want to do something with C and you're looking to extend PHP, then maybe this is for you. And there's PHP minus parser, which is a brand new project, just written by some college student. If you're looking to extend PHP or do weird stuff to the parser, then maybe you want to fork that on GitHub. For plain and simple use, I would try something tried and true, something tested, like PHP Depend. This is an example of PHP Depend matching a string. Manuel Pichir is, I'm probably butchering his name. Manuel Pichir is the one who created it, the one who maintains it. He's also known of PHP Under Control. And as you can see, it gives you a tree-like object, a abstract syntax tree, with some really nice depth that you can use in order to do your own introspection of PHP code. Some resources, if you want to learn more. I highly recommend the first book, Domain-Specific Languages by Martin Fowler. I used the second book, the Dragon book, Compilers, Principles, Techniques, and Tools. And let me warn you, it is not light reading. But it is the book that compiler writers refer to as the canonical resource. DSLs by Martin Fowler is much easier to read. One favorite of mine, The Elements of Computing Systems, is also a great book that teaches you how to write a modern computer, including operating system and compiler for a high-level language, starting at basic AND and NOR gates. Little light on the compiler theory, but pretty neat book. As I said, Twig and Gherkin have excellent implementations of a predictive parser. If you wanna, if you're stuck and you're looking for a way to go forward, then those are excellent projects to look at. Smarty uses the PHP parser generator, which, if you're interested in that, might be interesting to look at. One other resource I want to mention is Nathan's University, which is a guy called Nathan, which is doing a free online university on how to build and parse a general purpose language using peg.js. Which, one thing I didn't mention, there are parser generators for peg nowadays in almost any language. So if you define your language in terms of a peg grammar, then it shouldn't be that hard to port, say, our query language that we validate on the server side also to the client side, where we also interpret it and can immediately detect errors in the grammar or errors in the input. So that's it. Everyone's still awake? This joined in. Please rate me. Let me know how I did. Let me know what you thought of the subject. And this is my Twitter, email, SlideShare. Old slides on there now. I'll upload the new ones after this talk. And QueryLang is up on my GitHub. Check it out if you want to learn more. Any questions? Yes, Joris. Oh, that's a good question. He asked, why doesn't PHP Depend use a tokenizer of PHP? As some of you may know, PHP has the function token_getAll, which allows you to use the PHP lexer to transform PHP code into a token stream. And PHP Depend explicitly did not use that because they want to be able to run on a PHP 5.2 environment, but still parse PHP 5.4 code, which is one of the pitfalls that you have to. I mean, token get all is pretty nice, pretty sweet, but if you want to keep up with PHP, then you might want to use your own tokenizer. Any more questions? Okay, that's it. Thank you.
DPC Radio is a production of iBuildings. The materials presented are copyright of the speakers. This episode is released under a Creative Commons Attribution, Non-Commercial, No Derivatives 2.0 license. iBuildings is a full-service web development company specializing in PHP development. For more information on how we can help you with your next web project, visit our site at ibuildings.com. Thanks for listening, and we hope you'll join us again for DPC Radio.